the geometry of a circle to its equation. So a circle is really just by definition a set of points that are some fixed distance, which we call the radius, from a fixed point, which we call the center. Right? We all know how to make a circle, right? If you with a compass, you fix a point and then you fix a distance and you go around. The equation, the standard form for this equation of a circle looks like this, where h and k are the coordinates of the center and r is the radius. We call this a standard form. The reason that this is a standard form, now notice, certainly we could do some algebra. We could like multiply everything out and maybe combine like terms and see what we get. But this is the standard form. Because if I'm looking at an equation in that form, I immediately have a picture in my mind of where the circle is and how big it is. I know its center and I know its radius. And that's not always the case if something's all multiplied out. The reason that this is the standard form, or that the reason that the equation looks like this, really is just we're going to go back to Pythagoras. So here's an arbitrary circle. I put its center in the first quadrant, but everything we're about to do is also valid if I put the center anywhere else. Thank you. So, and it's some radius, right? So this is fixed. That's the center. This point over here is just any point. I could have picked any point on the circle. That's arbitrary. What I'm going to do right now, what's my favorite thing to do in the plane?
Drop a perpendicular.
Yes, I'm going to do a couple of them. So, that one and that one. Because what do I have now? I've got a right triangle. And do we know the coordinates of that point? Yeah.
Or y minus k.
Well, so I think you're looking at this distance, but I'm just talking about like the coordinates of this point at the bottom. Like what's the x coordinate?
So that would be the x2 minus x1 plus y2.
What are x1 and y1 and x2 and y2? So what is the x coordinate of this point? What's that?
X minus 8.
It's x, right? It's straight down from this point above it, right? So just plain old x. Yep. What's the y coordinate? K, yeah, because it's straight across from the point over there. So now let's go up here. What is that vertical distance? How do we get a vertical distance?
That's y minus k, right?
Yep, top y minus bottom y is y minus k. And what about the horizontal distance down here? X minus h. Right x minus left x is x minus h here. Okay, now what are we going to use? Pythagoras, yeah. Okay. So Pythagoras says that if I take the sum of the squares of the two legs, I get the square of the hypotenuse. So that's x minus h squared plus y minus k squared equals r squared. Which is of course precisely the equation that appears in the definition above. Fun.
So that's when we're searching for radius.
Well, it's not necessarily. I mean, I guess it could be, but this is us just seeing with our own eyes why the standard form of an equation of a circle looks like this. So the standard form is awesome because there's information that I can get from about the circle right from the equation while doing very little work. So one of the things I want us to observe here, like when we found this, derived this form, In the parentheses, it's x minus h, right? We're subtracting that x coordinate of the center. And then y minus k, we're subtracting the y coordinate of the center. If we look at this next example, it just says find the center and radius. So what should the coordinates of the center be? 1, negative 2, right? Because we're going to switch the signs. Wait, we're always subtracting that coordinate. So we're subtracting 1, so that's why the x coordinate is 1. We're here, we're adding 2, but that really means we're subtracting negative 2. And the radius is 4, because on the other side of the equation is the square of the radius. And the radius is always a positive value. It's a distance. So when we're thinking about taking square roots, we don't have to worry about plus or minus. So there's one where they gave us the equation, and we kind of got some geometric information about it. This next one is a little bit different. Here they're giving us geometric information, and they want us to find the equation. In this chapter, those are the two varieties of problems we generally do. Either they start out giving us algebraic information and ask for geometric information, or vice versa. So we know the center is 2, 1. They don't tell us the radius, but they do tell us that it passes through the point, 4, 8. So I'm going to just start by writing out standard form and then filling in what I can. I know the center, so I've got x minus 2 squared plus y minus 1 squared equals r squared. I just don't have the radius. All I need is r squared, right? And then I'm done. Now, they tell us a point that it passes through, and so here I'm going to say this like several times this week. I'm going to say it like really clearly right now. I'm going to like write it down. If I know the coordinates of a point that's on a curve, I can substitute those values in for x and y. That is precisely what it means to be a point on a curve. It is that the coordinates of that point satisfy the equation, right? That's the relationship between the equation and what it looks like in the plane. So if I know that it passes through the point 4, 8, yeah, I can plug in x equals 4, y equals 8. So let's do that. So we get 4 minus 2 squared plus 8 minus 1 squared equals r squared. Look, there's an equation that's all set up to just give me the value of r squared, which is the only piece of information I need to finish this problem. So what, 2 squared is 4 plus 7 squared is 49. So we get 53. So now I'm just going to plug that in up here. So we get x minus 2 squared plus y minus 1 squared equals 53. There's the equation. Questions? Okay. I'm going to...
Oh, I'm sorry. Is that, so that's standard form?
Yeah, this is the standard form here. General form is what I would get if I multiplied, like if I FOILed this out and I FOILed this out and I combined some like terms and stuff. So we're gonna next class on Wednesday. We're gonna see how we can. We're gonna first of all understand how useless general form can be, and then how we can perform magic and turn general form into a standard form, which is very useful. Yeah, me too. About whether or not you want to have a quiz Friday.
So wait, the test is next week.
Yeah, a week from Friday.
So we're getting the problem set on Friday. And we'll have to...
I've got the problem set ready to hand out today, actually, and it'll be due a week from Friday. So which is, reminds me, don't leave. Don't let me end class without handing it out. Okay. Henry, it looks like you're going to go blind back there. Is that shade? Is that sun bothering you? You okay? All right. Okay, so we're going to return to this. We'll decide Friday, but give it some thought between now and next class, and then we'll make our decision. Who has questions, or what questions are there about what we did last time, or the exercises, or anything like that?
Finding equal intercepts that passes through a single point.
Yeah.
Is a little
Which one is that?
21.2, problem number 17.
So equal intercepts. Passes through five two. All right, so the first thing I'm going to do is I'm just going to kind of sketch. I'm going to plot the point. There's one thing for sure that we know, like one very concrete thing we know about this line, is that it passes through the point 5 2. Now, if it has equal intercepts, that means that they are also going to be the same sign. So either they're both negative intercepts, which would be like this, right? Or they're both positive intercepts, which would be like this. So what quadrant, like what, do we think they're positive or negative intercepts? They've got to be the positive intercepts, right? So we don't know what the intercepts are, but we can, I'm just going to kind of, whatever they are, I'll call it, maybe this is A0 and 0A. If it has equal intercepts, forget about the point 5 2 for a second, okay? If it has equal intercepts, what is its slope? Close. Is that what? -1, right? It's because it's going downward, right? So it goes down and then over. So we know that the slope is -1. We get a lot of this just by sketching. Like sometimes we don't know algebraically exactly where to start, but like we can get some inspiration or an idea, something to try if we kind of just sketch out and mark down something that we know about this line. So it has a slope of -1, and we know a point. So what can we do now? We could do slope intercept. We don't know what the intercept is yet, though. Yeah, if we do point slope, so we absolutely can do slope intercept. I think it's a little bit more direct to do point slope, just because we have everything we need to fill in. Right. So x1, y1 is 5 2, so we get y minus 2 is equal to -1 times x minus 5, and we could put it in slope intercept form. Negative x plus 5, and then we'll add 2, negative x plus 7. If we did slope intercept, it might just be like 1 or 2 more steps. It's not like it's a huge difference. Y equals mx plus b. So let's see, y equals negative x plus b. How would we find b? So if we know the coordinates of a point that's on a curve or a line, what are we allowed to do?
Plug it in for x.
We could plug them in, yeah. So since it passes through 5 2, we do 2 equals negative x plus 5, and then
-5 plus b.
and then, oh, whoops, thank you. I was like, something's not right there. -5 plus 2, yeah, and plus b. Still something's not right. So 7 equals b, and then we just go in and plug it in. Negative x plus 7. Other questions? Okay. All right. Are you guys ready for, like, this is going to change your life? Some people, it's probably already changed your life in some ways. But I'm never going to stop preaching the gospel of completing the square. Ever. So let's do it. You know how when we were talking about the circle, and we were talking about how great the standard form is, because I get to do almost no work at all, and I get, like, there's all this low-hanging fruit. Like, I see that, you can look at the equation and immediately just see the figure, see the circle. You know where it is, you know how big it is. That's why it's standard. I could take this equation, and you're gonna think, like, why would I do this? And I agree with you, but I'm doing it just to make a point. What if I FOILed everything out, right? So this would be x squared minus 2x plus 1, and this part here is y squared plus 4y plus 4 equals 16, and then I could have x squared plus y squared plus, minus 2x plus 4y, and then what do I have, 5 on this side, minus, if I subtract 16, that's 5 minus 16. What is it? Negative 11? Okay. These equations represent the same circle. But if I look at this equation, the best I can do is say, yes, it's a circle. And then the reason I know I can do that is because it has both an x squared and a y squared, and the coefficients are the same. And we'll talk about other, like, ways that we might make that different when we look at other curves. But that's how I know it's a circle. Otherwise, I can tell almost nothing else, right? Like, here I know exactly where it is, how big it is. Here I know very little. So this sort of begs the question, like, what if I was given an equation in that form and I wanted to figure out its center and radius, right? This form of the equation is almost useless to me. I could tell it's a circle because it's, x squared and plus y squared, and the coefficients are the same. But the way we do it is we complete the square. You have probably seen, or anybody who took like pre-calc here has seen where you can complete the square to solve a quadratic equation. And now we're going to complete the square, not necessarily to solve the equation, but just to rewrite an equation. And it works pretty much the same way. So here's how we begin. When we complete the square in a circle, notice that because we have both an x squared and a y squared, we're going to have to complete the square twice, like on each of those variables. So I'm going to do some organizing. I'm going to group the x term with the x squared first. I'm going to leave some space. And then y squared plus 8y. I'm going to leave some space. And I'm also going to throw the constant by itself on the other side. So it looks like this. So I'm going to just focus on one variable at a time. Let's complete the square on x. Does anybody remember, and it's probably been a while, so it's okay if you don't, there's something, we're going to be really clever here, and we're going to add the same thing to both sides of this equation, which we're obviously allowed to do, but we're going to try to be really clever about what we choose to add to both sides. Does anybody know what we add or how we pick it?
It's a half of the coefficient.
Half of this coefficient?
Times 2, right?
Not times 2. Squared. Yeah. So I take whatever that coefficient is, cut it in half, square it. So I'm going to take negative 3 and square it and add it to both sides. You might wonder, why don't I just say plus 9 plus 9? And you're certainly welcome to do that. I like to write it this way because it kind of helps me remember what I'm going to do in the next line. Let's do the y's now.
So 4 squared.
Mm-hmm. So let's look at those x terms. That those first three terms, x squared minus 6x plus 9, is a perfect square. It will factor it. If we were to unfoil it, if we factored it, we'd get two of the same factor. We're guaranteed, because we were so clever, that it's a perfect square. That's what a perfect square looks like. It's just something all squared. What goes inside?
X minus 3.
X minus 3. Right, so you just take the x, you take the negative 3. Next. What is y squared plus 8y plus 4 squared?
Y plus 4.
Yeah, y plus 4 all squared. And then over on this side, we'd have a little arithmetic to do. 9, so 24 plus 9 plus 16.
49.
49. Perfect. So this is standard form. What's the center?
3. Negative 4.
Yeah. And the radius? 7. How great is that? Completing the square is not just something that allows us to solve a quadratic. Completing the square is not just the most enjoyable way to solve a quadratic. It is also just allows us, I mean, right now, I think we're even seeing how much more powerful it is. I'm not just getting a solution to an equation. I'm actually being able to rewrite, manipulate this equation so I can get a picture of like where this is. You want to do another one? Uh-huh. Okay, so what do we notice about this equation?
It's a circle, but we need this divided by 4.
Yeah, okay, so there's two things I heard, both of which are important. It's a circle. How do you know it's a circle?
Same coefficient and the x and y squared.
Right, yeah, so they're both plus 4 coefficients on the x squared and the y squared. And you said something after that.
It needs to be divided by 4.
Yeah, so when we complete the square, we always want to complete the square on plain old x squared, or plain old y squared, not 2x squared, or negative x squared, or 4x squared. So the way we'll start is we'll divide through by 4. Now, so I heard another observation over here.
There's no other x.
There's no plain old x term, right? So that's great for us because that means we don't need to complete the square on x, right? Like x squared itself is already a perfect square. We're just going to have to complete the square on y in this case. So let's divide both sides by 4. Leaving some space after the 4y term. Now what do we do next?
Negative 2 squared.
Mm-hmm.
To both sides.
So we have x squared. If you like, you could even write that as like x minus 0 squared just to like reiterate, but most people wouldn't, and that's fine. Like, so it's really up to you if you want to write it that way. What's the perfect square here?
Y minus 2.
Y minus 2. We were so clever in choosing to add the square of negative 2 to both sides. And then 9/4 plus 4 is 16/4, so that's 25/4. So there's standard form. What's its center?
0, 2.
Mm-hmm. And what about the radius?
5, 2.
5/2, yeah. Because, and this is a good like little reminder, if I take the square root of a fraction, You could split up radicals over division. So it's root 25 over root 4.